Good day everyone. So I am here to discuss our topic which is lesson 14 impulse and momentum. So let's begin our discussion with momentum. What is momentum? I know you heard of this word, but what really is it? This word is used in everyday conversation and means about the same thing in physics. Now, let's define first the momentum. Momentum is the product of the mass and velocity of an object. It is usually abbreviated as symbol P. In equation form, momentum is P equals m times v, or momentum equals mass times velocity. Mass measured in kilogram times velocity measured in meter per second results in a momentum with units of kilogram meter per second. Momentum is a vector that points in the same direction as the velocity. Next, the impulse. Impulse is the product of the average force and the time interval over which the force acts. The equation form of impulse equals G, which is represented by impulse equals F, or average force times time interval, or T. The SI unit of impulse is Newton times seconds, or in times is. Impulse is a vector that points in the same direction as the average force. Next, Newton's second law. The common definition of a force is any push or pull. A more interesting and useful definition is any interaction between two or more objects. Newton's second law can explain that interaction and the resulting change in motion. If acceleration is directly proportional to force, this means a large force causes a large acceleration. Then, if acceleration is inversely proportional to mass, this means a large mass results in a small acceleration. This relationship is written mathematically as F equals m times a. So the Newton's second law equation is F net equals m times a, which is the substitution results in the following formula is the result of the two new concepts. Now let's proceed the impulse momentum theorem. Remember, Newton's second law is F equals m times a. When Newton first wrote his second law, which is F equals m times a, he wrote it first as F equals change in momentum over change in time. Since the change in momentum is equals m times change in velocity, the equation form as F equals m times change in velocity over time. Then, since change in velocity over time is a definition of acceleration, the equations form as F equals m times a, which is the equations of Newton's second law. Next, substitute the definition for acceleration. So acceleration is defined as E equals change in velocity over change in time. Next, substitute. Since the Newton's second law is F equals m times a, now let's substitute the acceleration, which is F equals m times change in velocity over time. Next, rearrange. Rearrange the equation so there are no terms in the denominator. Since the equation is F equals m times change in velocity over change in time, so let's multiply both sides by quantity of t or quantity of time. So the new equation creates as F times change in time equals m times change in velocity. So now let's proceed the examples. So we have here the 5 examples. Example number 1. A freight train moves due north with a speed of 1.4 meter per second. The mass of the train is 4.5 times 10 raised to the power of 5 kilogram. How fast would an 1,800 kilogram automobile have to be moving due north to have the same momentum? So first, let's solve the freight train. So kay ang gihisgutan sa problem is momentum man. So let's apply the equation of momentum, which is P equals m times v. So since the mass of the train is 4.5 times 10 raised to the power of kilogram, and the speed or the velocity of the train is 1.4 meter per second. So now let's multiply the value of mass and velocity, which is the momentum of the train is 630,000 kilogram meter per second. And next, let's solve the automobile or the auto. So same gihapon nga equation nga to ang gamiton sa pag-solve sa auto. So the equation of momentum is P equals m times v, or v equals P over m. So the value of momentum or the value of P is equals to 630,000 kilogram meter per second, and the mass of the automobile is 1,800 kilogram. Since kay naa mas la unit sa kilogram, so ato siyang i-cancel out. And now ang 630,000 ato ang i-divide sa 1,800 kilogram. So the answer or the velocity of the automobile is 350 meter per second. Then examples number 2. A volleyball is spiked so that its incoming velocity of positive 4 meter per second is changed to an outgoing velocity of negative 21 meter per second. The mass of the volleyball is 0.35 kilogram. What impulse does the player apply to the ball? So the given here is the incoming velocity or the initial velocity is equals to 4.0 meter per second, and the final velocity is equals to negative 21 meter per second, and the mass is 0.35 kilogram. So ang formula nga ato ang gamiton is the impulse momentum theorem. So J equals change in momentum, or m times final velocity over m times initial. So the mass here is 0.035 kilogram, and the final velocity is negative 21 meter per second. minus 0.35 kilograms times 4.0 meter per second. So the answer or the impulse of the given is negative 8.75 Newton second. Example number 3. A football player kicks a ball with a force of 50 N. Find the impulse on the ball if his foot stays in contact with the football for 0.01 seconds. So, kay ang gipangita is ang impulse man. So, let's apply the equation of impulse which is J equals F times T. So, since the average of force is equals to 50 N and the time interval is equals to 0.01 seconds, so now let's multiply the value of F and T, which is 50 N times 0.01 seconds. So the impulse of the given is 0.50 newtons seconds or 0.50 ns. Example number 4. Determine the momentum of a 40-kilogram man moving southward at 2 meter per second. So in this problem, let's apply the equation of momentum, which is P equals m times v. Since the mass is 40 kilogram and the velocity is 2 meter per second, now let's multiply the value of m and v. 40 times 2, which is the momentum, is equals 80 kilogram meter per second southward. Example number 5. A force of 20,000 is exerted for 5 seconds on a 90,000 kilogram mass. What is the impulse of the force? Since the equation of impulse is J equals F times T, so the average force or the force is 20,000 N and the time is 5 seconds. To get the impulse of the force, let's multiply the value of force, which is 20,000 and the time, which is 5 seconds. So the impulse is equals to 100,000 Ns or 100,000 newtons second.